Hello, scrappers. Well, welcome to part one of what is going to be a multi-part series. And I'm not sure exactly how many parts are going to be in this series. I don't script things out that well into the future. Probably at least 3, 4, maybe 5 parts. Part one here is going to be on transistors. We're going to talk about them. But in the future, we'll talk about IC chips. We'll talk about connectors and fingers. We'll talk about hidden gold and precious metals that is on boards where you don't see anything that looks like gold or precious metals. And there may be more stuff in the future too to talk about. But for today we're going to talk about transistors. And if you hang around to the end of the video, there'll be a little bit of bonus content for those who stuck it out. I'll talk a little bit about another component on circuit boards that has gold in it. Alright, let's get started. And I'm going to start with transistors in this series because, you know, I got a question from someone on one of my recent videos when I was scrapping out the Beckman DU64 spectrophotometer. I'll put a link to that video up here in the upper corner. You can check that out if you want. But somebody was asking about transistors, and we had a little back and forth in the comments. And I had already been thinking about doing this series, so I thought, well, I'll just start off with transistors because they were going to be part of this series anyway. So here we go. So in front of you, I've got an example of lots of different types of transistors. As you can see, they come in lots of different sizes, from pretty darn big down to really, really tiny. Barely see them. And if you totally depopulate your boards, like I do, I totally depopulate the boards. I take everything off of my circuit boards, and then I sort through the stuff, and I keep the good stuff, and I toss the bad stuff. Well, if you totally depopulate your boards, like I do, you're going to find a fair number of transistors in the debris that comes off the boards. And the great thing about transistors is most of them contain at least a little bit of gold. I'm not going to lie to you and tell you that there's a lot of gold here. There's not a lot of gold here. There's just a little tiny bit in each transistor, and I'm talking a tiny bit, but it adds up. Over here I've got a bag full of transistors that I've harvested, and this is just lately. This is recent. I had a bag that had 5-6 pounds of it. Sorry, it's getting windy. It always gets windy on days I want to do videos. It's very annoying. I hope you can hear me okay. But I had a bag with 5 or 6 pounds of transistors in it, and I processed them, and I got, you know, a few grams of gold. So that's what convinced me to continue saving the transistors. I didn't know if I was wasting my time saving them up to that point. You know, I would sort through all the stuff that comes off the boards when I depopulate them, and I would save the transistors, and pretty soon I had a big bag of them, and I'm like, well, I don't know if there's really anything here. I went and processed them, and sure enough, I got a couple grams of gold, and I'm like, okay, cool. Transistors are worth keeping, but you need a lot of them. Like I said, I had like 5 or 6 pounds of transistors accumulated before I processed them. And I'm going to let it build up that much again. So how much have I got now? I don't know, maybe only a pound. So I got a long ways to go before I do another batch of transistor processing, just to make it worthwhile. And I'll talk a little bit about how I process them. Different transistors I do a little differently. We'll go over the different types of transistors you might find when you're depopulating your boards, but I've also thrown in a few things that aren't really transistors, but they're kind of kin of transistors. They're small IC chips, actually, that are in the same package as transistors. I process them as I process transistors. And actually, you know, this is an IC chip, this is an IC chip. These are actually kind of a bonus, because the more legs something has, generally the more gold bond wires it has inside it. So I will toss these tin of transistors, as I call them, these small IC chips, in with the transistors, and I get a higher yield that way. So, but the types of transistors here, it's separated broadly into 2 classes. You've got your power transistors up here, and they're the big ones with the big chunky legs on them and the built-in heat sinks. I mean, this TO3 style transistor here, it's almost all heat sink. It's a big, heavy chunk of metal. And it's to absorb all the heat generated by the little transistor die inside, which is doing the switching. And this can handle probably 10 or 12 amps of power at the very least, switching. And it will generate some heat doing that, so you got to get the heat away. So it's got a big, heavy metal case around it, and this is actually normally bonded to a great big, heavy aluminum heat sink with a fan on it to get rid of the heat. These are power transistors. They could also be in these 3-leg packages, 2 TO220 packages. You might get Darlington transistors, which is 2 transistors in one package. You might get also voltage regulators in these packages, which are actually another type of integrated circuit, but again, it's only a 3-leg package. But you process them just like transistors, at least I do. And these, again, these are designed for handling power in the area of amps. So they have a big metal heat sink up on top of them. They've got big, heavy legs. These are usually bolted to an aluminum heat sink, and it takes a little effort to get them out of the equipment. But it's generally worth it. They pile up. And then these over here, these are all surface mount, but they're the same thing. They are power transistors, or in this case, these are power diodes. But these are surface mount, so these are soldered right onto the surface of a board, and they'll come off when you depopulate the board. And I just throw these in with the power transistors. And what differentiates the power transistors from the signal transistors basically is just the amount of metal that's there, the size and the amount of metal. These all have a built-in copper heat sink, generally tinned, which is why they're shiny silver, but a built-in copper heat sink to take the heat away from the die. So I process these a little differently than I do the small signal transistors, just because the amount of extra metal that's there that I have to deal with. So I segregate them. When I process them, there'll be a demarcation. The small signal transistors go through one path, and the big power transistors go through another path. Now, that being said, I don't generally process these big TO3 style transistors because they're just not worth the effort. There is not enough gold in them to make them worth the effort of trying to get it out. You're probably best off just selling them as scrap metal, to be perfectly honest. I've opened up a couple of them, and they have really heavy leads in them, and the leads are generally copper. I suspect there's a little dot of gold at the point where they touch the dies just to make good contact, but there's not enough gold in them to make them worthwhile. All these other transistors will have some little bit of gold wire in them. Just a little bit. Like I said before, it's going to take a lot of transistors to add up to a lot of gold. Alright, as for the small signal transistors, well, these handle currents like in the milliamps generally, and they're a lot smaller. Now, that's not always the case. Some of these smaller surface mount transistors can probably handle an amp or two, and you'll see a lot of these on computers, telecom equipment, but they get pretty small pretty fast, and you get down into the milliamp range. And then you've got these through-hole ones here. These are small signal transistors in the milliamp range too. And you'll see a lot of these on equipment. On the older equipment, they'll like have a metal can package on them. And if you're really, really lucky, I hope that's showing up in the video, the legs on these transistors are gold-plated. You know you're working with old stuff generally if you've got metal can transistors with gold-plated legs. So yeah, you don't see that much these days anymore. Every once in a while, though, you'll get some high reliability piece of equipment that still has gold-plated legs and metal cans on the transistors. Most of the time you'll get these little D-shaped epoxy blob type transistors with the legs sticking out that are not gold-plated. I'll tell you what, every once in a very great while, I'll find stuff from the 60s or 70s where these big transistors have gold plating on them. But that's getting pretty rare. But keep your eye open for it. Grab it if you can find it. But yeah, if you depopulate your boards totally like I do, you'll find all kinds of transistors in the resulting mess. And you know, I'll spend an hour or two after I depopulate a batch of boards just sorting stuff out into different categories, and I always have a transistor category. And as you can see, they get pretty darn small. All right, let's have a look at some of the boards and where you'll find transistors on the boards and what they look like. All right, so here's the board that started the whole question about transistors in an earlier video. This is the main computer board out of the Beckman DU64 spectrophotometer, and I was pointing out that it had some transistors on it. It's got a lot of other good stuff on this board, some of which I've already harvested. But so here's transistors. Here, 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 and a few other places on the board. And these are the sort of D-shaped blobs I was telling you about. I believe TO93 is the package, or 94, I don't know. I should have done a little research before I started this video. My memory's a little rusty. I used to know all these transistor packages because I used to be an electronic engineer back in the day. So we've got some transistors on this board. In one of my last videos, I depopulated an Emerson VCR DVD player combo, and it had a lot of old school electronics on it. It must have had 50 of these type of transistors on it, but there was really not much else on the board I wanted, so I just took diagonal cutters and I cut all those transistors off and kept them. So that's one way to do it if you don't want to depopulate the board. This board, of course, though, is going to get depopulated because it's got a lot of other stuff I want on it. It's got a lot of ICs. It's got a couple of metal can components over here. Now, these are not transistors, though. These are IC chips, and sometimes the IC chips come in the metal can package too, as well as in these dual inline packages and various surface mount packages. So, similar to transistors, but not exactly the same thing. So if you've got a lot of these, you could probably process them the same way as your metal can transistors. So this board started it all, but got lots of other boards here with transistors on them. So this board right here is some sort of power board. I don't even remember what I got this out of. It's been bouncing around my shop for a while. I need to depopulate it and get all the stuff off of it, but it's got lots of transistors on it. They're all over the place on this thing. And it's got one of these big power transistors here, or a regulator. I'm not sure which. I'd have to look up the number. And here's another one over here. And here's another one with a heat sink clipped on it, which makes it kind of hard to see. And then here's two more attached to these big aluminum heat sinks. So there's a lot of transistors on this board, and they'd be pretty easy to harvest even if you didn't want anything else off the board. Just get your diagonal cutters out, clip all the transistors off. Take you 2 minutes, and you can just add them to your collection. Power boards is where you usually find the transistors in modern electronics. There's not a lot of discrete transistors in most things. A few here and there generally. If you get the older stuff, the pre-IC stuff, you might find a whole lot of transistors on it. Because what integrated circuits are basically is a whole bunch of transistors in one package for the most part. But in older stuff and in power boards, you'll find discrete transistors. Like here's a transistor down here, here's a power transistor over here, here's another power transistor attached to this big heat sink over here. And I hope I'm keeping this stuff in reasonable focus. Yeah, okay. So, okay. Now here's an interesting board. This is a PC expansion board. I think it's a something for driving a CNC machine, I think. And it's really easy to overlook the transistors on this board because there's so much other good stuff. It's covered with IC chips. It's got gold fingers. It's got gold connectors. It's got gold pins, header pins. It's got a connector over here with gold in it. It's just gold everywhere. And the little lowly transistors kind of get lost in the shuffle, but they're there. So, you know, don't overlook them. Okay, maybe they shouldn't be your highest priority on a board like this. Get the good stuff for sure. But, you know, there's transistor, transistor, and yeah, transistor, transistor. Yeah, there's a few transistors on this board, so don't overlook them. Don't let the gold dazzle your eyes and forget to collect the transistors. Now, on more modern equipment, the transistors aren't quite so obvious. I hope this is showing up. We've got two little surface mount transistors here. Got sort of a medium-sized one here and a small one back here. And this is a controller off of an old IDE, parallel IDE disk drive. So it's got a couple of transistors on it, probably for turning the spindle motor on and off, I would imagine, and doing other things. So anything that turns a motor on and off is probably going to have a power transistor on it, and you know, it'll be there somewhere. Here's another little board. I don't remember what this board came off of. I have so many boards, it's hard to say. There's a little transistor on it, surface mount. This board here, okay, where is the transistor on this board? Oh, there it is. Wow, that's a tiny one right there. I knew this board wouldn't be in the pile for this this video if it didn't have a transistor on it somewhere, but it took me a bit to find it. It's right there, and I hope you can actually see that. I can't really zoom the camera in anymore. So let's see, this board here has a fairly large size surface mount transistor on it, and that's the only one I see. Yeah, okay. So that's where you'll find transistors. Here's another board. Now, I was talking about old school analog electronics, and this is the amplifier for a photodiode from the spectrophotometer I took apart a few videos back. So here's the photodiode that was measuring the illumination passing through a sample. And this has an amplifier. It's got a little IC chip and a metal can on it. But over here, it's got a couple of transistors that were part of the analog circuitry. So, like I say, if you see analog electronics, look for transistors. Yeah, old analog electronics is a good place to find a lot of transistors. Pre-IC stuff, audio stuff, old stereos, tuners, receivers. Older televisions have a lot of transistors in them. Stuff you might find beside the road on trash day that people have thrown out because they've upgraded to the modern flat screen and you know, better stereo equipment. You know, the old stuff, the phonographs, they've got transistors in them. So, you know, you may look at that stuff and think, it's not worth scrapping out, but hey, at least clip the transistors out of it. It just takes a few minutes, you know. And then this board right here, this board controlled a label printer. And just look at the power transistors on this board. Well, they're not all power transistors. Some of them are regulators. Some of them are diode arrays. But, you know, they're all basically built the same way. I mean, they're huge. I mean, just to give you some idea how big some of these things are. They're gigantic, you know. And over here, I was talking about transistors and their kin. These over here, these are actually power integrated circuits, probably used for running, this was a thermal transfer printer if I remember correctly, so this is probably for driving stepper motors, I would imagine what these were for. So they're in similar packages to the power transistors, but they have a lot of legs on them. But you can process them just like power transistors. And remember what I said in the beginning, more legs is better because that means more gold wires going to the little die inside. So basically, this is an integrated circuit designed for handling a lot of power. You know, this is an integrated circuit for handling digital signals. But this is an integrated circuit for handling a lot of power. And that's how they build them. They build them like these power transistors. Very similar. So this board has a lot of power transistors and their kin on it. This is a good board to scrap out and get the parts off of. There's a lot of other neat stuff here too. There's IC chips and copper and other things on this board that would interest a scrapper. So don't pass up the printers. The printers have good stuff in them. So here's another control board for a printer, and as you can see, we've got right here another. This is a surface mount. Again, I think this is a motor driver of some type, either stepper motor or just a rotary motor for advancing the ribbon. Or this was a thermal transfer printer, so advancing the ribbon or something. I don't know. Advancing the labels. There's one on this side, and there's another one too on this side. So again, these are not technically transistors, but you can process them the same way as you process your power transistors. And you know, they've got more legs, so they got more gold. So this is a good find. So I've showed you where to find them. Then transistors come in lots of different types. This is by no means going to be a comprehensive explanation of the transistor types. You know, I went to school to learn that. There's lots of different types of transistors. There's your common BJTs. There's your Darlingtons, your MOSFETs, your triacs, your SCRs, your diacs. It goes on, and they all have slightly different functions, but they're all pretty much in the same packages. And you'll get pretty much the same gold yield from all of them. So don't worry about the types, other than maybe dividing them up like I have here between power and small signal transistors for your processing. So about process. When it comes to these small epoxy blob transistors and these smaller signal transistors over here, surface mount ones, I just process them with my IC chips. I just throw them in the same batch with my IC chips, and I process them the same way. And I have videos about how I process my IC chips, and in the future I'll come out with more detailed videos about how I do it, because right now it's kind of spread out across, I don't know, 5 or 6 different videos, the entire process. And I'll try to consolidate it into one video so you can see all the different steps in one process. That'll come, but it may be a while. These power transistors are a little different. These I will process separately. If you look at this bag, this is mostly power transistors in here. I will process them separately because there's so much extra metal here to deal with. So what I'm basically going to do is I'm going to put these in a batch of AP solution, and I'm going to let the AP solution, AP is acid peroxide solution, hydrochloric acid and hydrogen peroxide, and put a fish tank bubbler in it and just let it bubble away for a month, 2 months, whatever it takes to dissolve away the bulk of the metal. Now usually I will clip off as much of the metal as I can before they go in with my diagonal cutters, just to make the process a little quicker and easier, but the heavy heat sink that's built into these takes a while to dissolve away. You know, the remnants of the legs takes a while to dissolve away. Basically I want to get rid of as much of the junk metal here as I can, because this metal is just copper and tin. Yeah, copper is valuable. There's a way to get the copper back out of the AP solution, but that's probably a subject for another video. But I will dissolve away as much of the metal as I can, and then I will incinerate the bodies of them, and then crush what's left in a blender. Just crush it up into a powder, and then treat the whole thing with nitric acid to get rid of any other junk metal that's left after the AP solution treatment. And then what stays behind after the nitric acid treatment gets treated with aqua regia to dissolve the gold in it. The transistors, the smaller transistors, pretty much the same thing. I put them with the IC chips. They get their legs chewed off in the AP solution. There's much less metal here. It doesn't take nearly as long, maybe a week or two. They get incinerated, they get crushed, they get treated with acid, then they go into the aqua regia. Metal can transistors is a little different story. I am still doing R&D on how best to process them, but I will tell you, if they have gold plating on the legs, or like these have, they have gold plating on the bottom of the metal cans as well. Sometimes you'll get the whole metal can is gold plated, but that's pretty rare. First, I will put these through the Eco Gold X gold plating stripper to take the gold plating off before I do anything else to them. Then, at the moment I'm basically just accumulating them. I don't have that many. Metal can transistors are kind of rare these days. Once I get a bunch of them, I'll work out the best method for processing them to get the gold bond wires out of them, and I'll publish a video on that. But right now I'm just accumulating them. I don't have very many because they're kind of rare. So that's how I process them basically, and like I said, I have other videos on my channel showing how I process the IC chips. You'll have to watch a few of them to get the whole process. I will consolidate all that whole process down into one video in the future just so you can see all the steps in one sitting. But that's pretty much it for transistors. If you have questions about transistors, anything that I didn't cover, anything that I've confused you about, leave a comment, question in the comments section, and I will endeavor to answer your question as best I can when I can. Alright, let's move on to the bonus content I promised at the beginning of this video. Okay, for our bonus content today, we're going to talk about diodes. Diodes are kind of ancestors of transistors. They're generally a two-terminal device. Transistors are generally a three-terminal device. I don't know if I mentioned that up front at the transistors, but transistors generally are a three-terminal device. Diodes are generally a two-terminal device. Now, the diode effect was discovered first, and then transistors are an outgrowth of the physics behind diodes. So what a diode is, basically, is a one-way valve for electricity. It only lets electricity flow one way through a normal diode. Now there's exceptions to that. There's Zener diodes. These are Zener diodes over here, which will let electricity flow the opposite direction once it gets above a certain voltage, but not below a certain voltage. So there's lots of different kinds of diodes, just like there's lots of different kinds of transistors. There's your regular one-way valve type diodes. There's Zener diodes that are one-way valves until the voltage gets above a certain point. There's fast recovery diodes, there's Shockley diodes, there's all kinds of diodes, and there's light emitting diodes. These are diodes, again, that act like a one-way valve for electricity. They only let the electricity flow one direction, but they have been optimized. Oh, got a bug amongst my diodes. They have been optimized for emitting light in the process. The silicone or gallium or arsenide or whatever semiconductor they're made of has been doped with materials that emit light as the electricity passes through them. So you've got lots of different types and colors of LEDs. This is just a small selection. They come in every color of the rainbow these days. Used to be, when I was young, there was only red. Then along came, yellow, green, blue. Once they had ultraviolet, they could make any color in the rainbow by putting phosphors in front of the ultraviolet light. But that came along just a few years back. Well, it seems like just a few years back to me. And then you've got these like 7-segment displays, which are basically groups of LEDs. So here you've got two 7-segment displays, so each of these is 7 LEDs in here, so you got 14 LEDs, plus you got 2 decimal points, so you got 2 more LEDs, so you got 16 LEDs in this package. And this package here has 9 LEDs in it, because it's got the 7-segment display and a colon. So this would probably have been for a clock, and this would be more of like for a calculator or something. So you've got a lot of LEDs in these packages. And each LED has a little bit of gold in it. In fact, most diodes of any description have a little bit of gold in them. These are small signal diodes over here. This is more of a power handling diode. This is a power bridge rectifier diode. This actually is a package that has 4 diodes in it, wired as a bridge rectifier. And this can handle several amps of current, hence the heavy legs on it. Most of these diodes are more in the milliamp range, especially the LEDs and these small signal diodes, just in the milliamp range. These diodes here can maybe handle an amp, but generally they have a little bit of gold in them. I'll talk a little bit more about how I process these and whether I process them in a bit, but first let me show you where you can find diodes. Alright, the beauty of doing diodes as my bonus here is because I can use all the same props as I used the first time around. So, we're back to this control board from the Beckman DU64 spectrophotometer. I showed you the transistors on it. Little tiny glass signal diodes here. And this is something else I wanted to talk about, the diodes, because of another question I got in one of my other videos quite a while back. I mentioned glass barrel diodes, and somebody's like, what are those? I've never heard of them. Well, they're basically diodes, and I had some here. There's a bigger example of one. I'll put down here so you can see it. Basically, the body of the diode is just a glass tube that they put the works inside and seal up. You got a lead coming out of either end, and inside you've got the tiny little silicon die or gallium arsenide die or whatever, and a little whisker of gold connecting one of the legs to the die. So that's a glass barrel diode. It's made of glass. It's a very common packaging, even though you've probably overlooked millions of them. So there's a couple here. Let's see, there's 1, 2, 3, 4 over here. And I thought I saw more on this board, but we'll move on and we'll look at another board. Okay, here's a board. This is a power board. This is where you're going to find almost every power board is going to have diodes on it. So we've got a big power diode over here. That's a big one. We've got another smaller signal type diode here, and a couple of other diodes here. Here and here, and here's a small glass diode, and here's another one over here. So these all contain just a little bit of gold. Let's see, here's this board. We looked at this board before. It's got a whole row of glass barrel diodes here. Here's one, here's one, here's one, here's a couple, here's one. The more I look, the more I see. Here's one. And then if I turn it around, well, actually I don't even have to turn it around. Here's a line of higher power epoxy case diodes down here. And if I turn it around, here's a bunch more. So there's a lot of diodes on this board. Power boards are going to have diodes on them. They're used for rectifying, which is basically allowing the current to only go in one direction. You got to do that to turn AC into DC. And they have other functions too. But power boards almost always have diodes on them. Let's see, this board here, this has got a whole bunch of really tiny glass barrel diodes here, 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 over here. But some of these big things that I told you were transistors and kin of transistors earlier on, these are actually power diodes and diode arrays. Some of these packages, let's see, which one is it? I know I saw it here. This one right here. This one right here. Notice it only has 2 legs on it. That's a power diode. That is not a transistor. That's a power diode. And one of these, I forget which one it is now, I think it's this one here, is actually 2 power diodes in one pack. So there's diodes here. Now you can process these just like you process your power transistors. You don't have to do them any separate, any differently. You can just throw these in with your power transistors when you're processing them. But I'm just letting you know that they're not all transistors. Some of them are diodes. Let's see here. This is a special kind of diode right here. This is called a photodiode. We looked at this earlier. So we have LEDs which are designed to emit light when electricity passes through them. A photodiode is a different animal. It's designed to let electricity pass through it when light hits it, and not let electricity pass through in the dark. So that's what a photodiode is. You won't find a lot of photodiodes in most electronics. They're usually buried inside other things. Like if we go back to this power board here, this little thing right here that looks like a little 4-legged IC chip, this is an opto isolator. And what it's going to have inside it is an LED on one side and a photodiode on the other side, or a phototransistor, very similar. And what it does is it isolates the low voltage side of the circuit from the high voltage side over here. You've got your line voltage coming in over here, at 120 or 240 volts depending, and you've got low voltage going out to your electronics here, 5 to 12 volts, and you've got to keep them isolated, otherwise you're going to smoke your electronics. But you got to get signals from one side of this board to the other, so they do it optically. They'll have an LED here that's sending a signal to a photodiode or phototransistor on this side, and they're totally electrically isolated from each other. In fact, you can see there's even a little break in the board right there, so that there's no connection between this side of the board and this side of the board to let the signals through. So that's where you'll find most of your phototransistors. They're buried inside other things. You won't see a lot of them on your electronics. This is an old postcode reader diagnostic thing from old PC computers, which I don't use anymore, and sooner or later I'm going to scrap out. But it's got two 7-segment displays here. It's got a bunch of LEDs on it, and on this side it's got another 7-segment display to display the postcode. So a lot of little red LEDs on it, which is kind of neat. And then right here I've got an old defunct headlamp that has 12 clear bright white LEDs in it, and I will try to get a picture of this. I don't believe the macro lens on my camera here will allow me to do it, but I'll rig up something and get a picture of it. You can actually see the gold bond wires inside these clear white LEDs. The actual dome top of the LED acts like a lens and magnifies it, and if you get close enough you can actually see the gold bond wires in there, which is kind of neat. And all these LEDs have those gold bond wires. You just can't see them in the frosted colored ones because you just can't see them in there, but in the clear ones you can see them. Oh, and back to this original Beckman board. Here's two lines of diodes I completely overlooked myself. So just show you how easy they are to overlook. These are slightly different package. They're sort of epoxy package, but they're blue. And how you can tell if it's a diode on a board or not, because it might be something else. It might be an axial capacitor, it might be a resistor, it might be something else. On a lot of boards, the number for it will start with a CR. CR12, CR11, CR10, CR9, CR8, CR7, CR6. This little glass diode down here is CR18. A lot of times they have a CR at the beginning of their number. Not always. That's not universal. On this board here, this is D24. So D for diode, CR for diode. Or over here, if you look at these tiny little glass signal diodes here, they must be Zener diodes because that's ZD8 something. That print is so small I can't read it, but I see the ZD part. So ZD. So, you know, there's lots of different ways that they're going to designate them as diodes. CR almost always means a diode. If the number starts with a D, it's almost certainly a diode. ZD, it's going to be a diode, a Zener diode. On this one back here, this big two-leg diode back here, D1. So they're calling that D1, and then these little glass barrel diodes over here, they are D5 and D6. So different board manufacturers are going to label them differently, but that's basically how you can tell whether you got a diode or not. It's going to be labeled either as CR something, D something, or ZD something. Okay, back over here. Here's something I completely forgot to show you earlier. These are tiny little chip diodes that are surface mount. Very, very, very tiny. But you can actually see the little whisker of gold in them through the clear front on them. If you take a loupe to them or a magnifying lens, you can see the little gold in there. So, diodes come in lots of different packages. In fact, I was looking diligently to find, I know somewhere I have some really great big high-powered diodes that come in a package with a big threaded lug on it to bolt on it to a heat sink, but I couldn't find them. And sometimes you get diodes in the same packages like you get these power transistors in, I've seen those before too, but they're diodes instead of transistors, but they're just in the same package, so the package to let the heat out when they're switching multiple amps. They get hot. So we've got like these diodes here are in epoxy cases, these diodes here in glass cases, these are in little plastic cases. I don't know, that may be transparent epoxy on there. These are epoxy basically. So with the epoxy ones, I will treat these just like I do my IC chips and my transistors, the epoxy transistors. I will process them exactly the same way. If I'm going to clip them off a board, I will clip the legs just as short as I can so that there's less material to deal with. Now that being said, I don't do a lot of diodes. Yeah, I'll do the LEDs because there's a lot of LEDs and stuff, and there's a nice gold whisker in each LED. And if I can, I get a lot of these little chip diodes. I took apart some Ethernet switches, and each board in that switch must have had a couple of dozen of these on it, and they all came right off when I depopulated the board. And I just, like I said, throw them in with my ICs, process them the same way. But, you know, and then I will clip these diodes off of a board if they're easy to get to, and just clip the legs off short. But big power diodes like this one, and these big bridge rectifiers, I don't generally bother with, because there's very little gold in these and a whole lot of junk base metal. Makes them very hard to process and get anything out of. There's just too much junk metal in here. Now these, there's a lot less metal. These, there's a whole lot less metal. Basically, the smaller the diode, the richer the return, because there's a lot less packaging there. But I don't bother with these because there's just not enough gold compared to the amount of other crap you have to deal with. Now this diode, I normally would not do anything with this diode because this is a big power diode, but like with the transistors, occasionally you get them with gold-plated legs. So you see this has gold-plated legs. This diode over here has gold-plated legs too. So I will treat them just like I do my gold-plated transistors. I'll run them through the Eco Gold X gold stripper and get the plating off. What I'll do with them after that, probably nothing. I don't have a good method for dealing with the glass diodes yet, but I'm working on it. That may be the subject of a future video. So like the metal can transistors, which I don't quite know the most efficient way to deal with yet, I don't know the most efficient way to deal with the glass body diodes yet. So I accumulate them, but I'm not actively hunting them either. You know, if I get them, fine, I'll keep them, but I'm not going to spend 20-30 minutes clipping them off of a board, you know, like this that has 50 of them on it. Not going to worry about it. I think diodes are one reason why refiners can manage to get a lot out of a board after we've taken all the good stuff off, because usually the diodes are still there, and each little diode still contains a little bit of gold. So, but of course the refiners can digest the whole board and separate out each and every metal from it. That's hard for us amateurs to do. Pretty much impossible, really. So it's up to you whether you want to go after all the diodes. For me, I'll go after the LEDs, and I'll go after, you know, these small signal diodes if they'll come off the board easy. If they're going to be a pain, forget about it. I'll just leave them for the refiner. I think they're probably more trouble than they're worth. And for power diodes, I don't even mess with them unless, on the rare occasions, they have gold-plated legs. Okay, I hope you found all this interesting and enlightening in some manner. If so, give the video a thumbs up, give it a like, and subscribe to see future videos. Press the little bell icon to be notified when they come out. There will be more videos coming out on this series in the not too distant future, and other videos too. I've got a lot going on, so there's going to be a lot of other videos coming out too. And thanks for watching. Have a good one. Keep it safe out there. Bye.